Hello and welcome to the lecture 9 of the Learning About Learning series, and we were actually looking at how the background conditioning prohibits the learning to tone CS when you are presenting in an non-contingent fashion. All right. So, there I was telling that how we were calculating the learning for the CS and the US presentations and for the CS here being tone, and we were also calculating the learning due to the background, which is omnipresent all throughout, and it does not come into existence until somebody, I mean, you have an US there. When you have an US at a point where there is no experimenter provided CS, then the animal associates with that of the background. So, we were actually calculating that, and in there what we saw was that you can actually segregate into the learning due to the background and learning due to the tone, and when you mark it out, we saw that whenever there is a co-presentation of the CS and the US, there is increase in learning for or increase in response for both the tone induced as well as the background. However, when there is no presentation of the tone, no presentation of the CS, but US alone, then the increase that you see is purely due to the background. And if there is sufficient number of such presentations had happened, let us see, like for example first, second and third, right. So, after this the fourth presentation, right, which has the tone and the background, I mean which is being present, which is similar to any of these the first trial, then in that case what is happening is that the amount of learning that the animal incurs for the tone I am trying to show here will be lesser than what it would have learned in the case where these shocks were not present. If the shocks were not present, then these terms would be 0, right, all of these terms would be 0. Since this is 0, and remember this is coming as a subtractive term. So, since this is 0, you are taking away some number from here, the learning that the animal could have incurred if only the shocks were not present would be higher, but because the shocks were present, these were non-zero quantities. As a result, it takes away more from the Vmax. As a result, the fraction that contributes to the learning of the tone is reduced, number 1, right. So, number 1 what we see is that the learning to tone is lesser than learning to tone when the CS is presented in a contingent manner, right, which is there are no let us call it as no US alone events. Okay. If we have two scenarios, a scenario 1 where there are no under no condition the US itself is presented. So, whenever the US is presented, there is always a CS. In such a condition, we call that as a contingent manner, right. That is when you say that the predictability of the CS, right, the predictable power of the CS of signaling a US shock is higher, right. In that case, you see the learning is higher too, naturally. However, in this case where we are measuring in the case of US alone or shock alone things were presented. So, the more the number of the US alone, you can actually see that this curve would have kept going up like that. The green here, yeah, the curve could have kept going up like that. The more the number of US that you are giving, so let us put it as dotted line, so it is a hypothetical case, then that much less the tone would have been. Say for example, right at this point, if you had to give us the tone and the background, right at this point, if you had to give the V tone in the blue we have been writing. So, the V tone would be 0, because the maximal learning, the V max, has been already associated to the background. Thus, you can see at the cost of not learning the CS and the US association, the animal learns to associate the US to the background. So, the CS here I am talking about the experimental provided CS. The experimental provided CS is the tone, and since the tone and the shock was provided in an incontingent manner, non-contingent manner, the shocks that were presented in the absence of the CS, in the absence of the tone, takes over or attributes an association to the background. The animal attributes the those CSS to the background learning. As a result, it thinks that becomes the dominant learning here. In an in between case where say right in this current situation, where you are presenting the CS and the US, like the tone, experimental provided CS tone, and along with the background. So, then even here what we see is that the tone learning will be moderate, right, that the tone learning will increase from, because the left out surprise element is only this much. In this, alpha fraction, alpha tone fraction would be added to this, right. So, this times the alpha tone would be somewhere here. Eventually, when you actually this plus the way you want to look at is this, you have to add this together this, which means actually you will be overshooting a little bit, quite a bit. So, it can be negative learning. So, we will go back here. So, we will take this as the term. So, when you do that, then we are going to add this number to this number. So, let us say somewhere around here at this point, light green, at this point when you add both of them together. So, let us say hypothetically we are around about here. So, whatever the small difference that we see here, right. So, that small difference, the alpha fraction of that small difference gets added to this. So, the tone gets increased by that small moderate amount, and the next time what is happening is that you are actually, when you are presented, the animal is actually overshooting the V max here. So, that is a special case. When it overshoots, what is going to happen will be a special case that we will see in a little bit. So, let us hold on to that, but the point I want to drive across here is that V background dominates and increases at the cost of V tone. Now, that is essentially the conclusion we have drawn from the initial experiment, right. So, the initial experiment was consisting of two groups. So, where the group A is where we have presented a random group where there are we throw in some of the USs in the absence of CS, while in the control group what was provided, what was presented is a contingent presentation of, which is whenever there is a CS, there is a US, and whenever there is a CS and only whenever there is a CS there is a US. Okay. You could have the omission of the CSs when there is a omission of the USs when there is a CS present. You can actually go back and do that analysis, you will see that it really does not matter there. However, the main crux of the matter is occurrence of the US in the absence of CS. That is what makes the difference between this control group, where we see a beautiful learning association between the tone and the shock, compared to the random group where this exact same thing is presented. In addition, you have few shocks where there is no CS. Okay. So, it is through this, that is a compound compound integration of multiple stimuli, and then the distribution of learning across all of this stimuli, and given the fact that you can have a maximum learning of V max, Rescorla and Wagner model incorporates the contingency. Just to summarize again, it is this ability of having a finite learning of V max and distributing that V max across several CS, that gives the ability of the Rescorla Wagner model to abstract contingency, extract out which are all the contingent stimuli and which are all not. Now, so these three cases kind of illustrates through these cases, we have 3 cases, we have illustrated how we can use Rescorla Wagner model to explain the observations we have seen so far. But the usefulness of the model, as I have been saying, is not in just explaining what the previous observations have been, but can it make new predictions. That is not obvious, at least at this or at the point in time where the model was proposed. The answer is a big yes. One of the crucial such predictions in this model that is coming out from this model was a notion or a concept of over expectation. We kind of alluded to that during our analysis of the random group learning, but let us look at it in a much more formal way. So, the Rescorla hypothesized that if this model were to be true, then directly coming out from this model he predicted not only a positive learning that should happen when you are presenting CS and US together, but under some unique cases when you are presenting CS and US together, there can be a negative learning. Negative learning itself is not surprising, right. We have already seen extinction happens, right. So, you can have negative learning when there is a Vmax set to 0, then the term can go to negative. That is not the point here. The point is you can have negative learning when you are presenting the CS and the US together, right. Extinction is about negative learning when there is no US, all right. You are correcting, or so to speak, you are learning to correct what you have learned before. Here he said under certain conditions, when I am presenting the CS and the US together, there can be negative learning. What kind of situations are these? Imagine a situation he argued. Let us say we take a CS1 and then pair it with a US, let us say tone here, and then pair it with a shock. There will be some amount of association that will be developed such that the CS alone can develop a CR. Now, you can do the same thing with another CS. So, different color, and let us say CS2, let us say light. From the same shock, exact same intensity and everything being same. So, clearly CS2 also develops the ability to elicit a response from the animal. So, let us call that also is CR. Now, take these two instances, they take these animals which had undergone training in both tone alone paired with shock, light alone paired with shock. Now, let us put in a situation where you are giving a compound stimuli of tone plus light or CS1 plus CS2 and pair it with a US, same shock. In this case, whether the response to the tone, will it increase, decrease or remain same, is not a given. That is what the model predicted. You would assume that in any case, so the CS1 is paired with shock, and next time again you are presenting the CS1 and pairing it with the shock, you are anyway going to increase, right, because you are increasing the contingency that it is happening. So, it should actually increase. It turns out that is not the case, at least that is not the case always. It depends on what level of response the tone and the light are able to elicit at the beginning of this compound stimuli, right. You can easily see this if you are following up our mathematical model, where what will we do is that in order to ask what happened or to the learning to tone or change in response to tone at the end of the compound stimuli, we need to write V tone equals alpha tone times V max. So, that is same because the US the shock intensity is same, frequency is same, etc. So, V max minus summation of V t plus V light. Now, you can imagine multiple scenarios here. A scenario 1 where this summation term, right, let us call this, I mean I like to write as this. So, summation of all the CS responses, if this summation term is equal to V max, case number 1. Case number 2 is greater than V max. Case number 3 lesser than V max. As you can see, if it is equal to V max, right, if both the light and the tone, the individual responses add up to the V max, then the response you will see for the change in response you will see will be 0. The tone delta V tone will be 0 if it is greater than V max. Now, that might seem little counterintuitive or inconsistent, because we said V max is the maximum response that the animal can have. So, in that case how can an animal animal's response be greater than V max. In fact, it does not. And individually when you test for the tone and the light, they may have responses, and those responses are less than V max, but this being a compound stimuli, it tries to respond. Now, when it is trying to respond, it tries to respond for both the stimuli, the light and the tone, and clearly it cannot respond beyond the V max. As a result, what it is doing is that maybe I am overreacting, I need to correct it, and that correction means a reduction in the V tone. So, if it is greater than V max, what you are seeing is that your delta V t is going to be negative, right. It is going to be lesser than 0, which is negative, and it is going to be negative by the it is going to decrease by the alpha t, right. I mean, the alpha t is again the scale by which the animal reduces or alters its response. That does not change, but the point is that it can go negative, right. So, the point here is this is an effect, he call it as over expectation. And this is a normal one, right. When the summation is lesser than V max, what you have is the V tone greater than 0. They alter their individual responses by some amount. Now, this is true for light or tone, but the point here is that you can have this negative responses where the animal later on when you go back and test for just the tone or just the light, you will see their response has come down compared to what it was before the presentation of the compound stimuli. So, that is pretty counterintuitive. That is, I mean, the fact that the effect of a compound stimuli is not cannot be predicted just by one as one, but it can have 3 different I mean, it can have 3 different directions consequent to the fact at the start of the compound stimuli what is the level of learning for the tone and the light. Now, that negative learning is a clear prediction that is coming out from Rescorla and Wagner model, and it was not known before. And Rescorla went ahead and tested these observations in his 1971 paper. We will see some of these results in the forthcoming class, but the thing that the point I wanted to convey here is that this model with its very simple one line mathematical summary of the assumptions captures not only whatever the observations have been made on associative learning before, but it can actually make useful and very non-intuitive predictions that was not known before. And now and people have gone ahead and tested how true are these predictions, and the answer is true. It is definitely true that you would have this negative learning, and the over expectations, corrections to the over expectations can be done through this process. All right. So, with that I would like to bring to an end the description of the model per se, but what I will like to point out is that with any such model there are limitations. Howsoever good they are, there are limitations, and these limitations we will look at it one at a time, like two or a couple of them. But in by no means I am saying this is the model that captures every single aspect of associative learning, but this is the model that is proposed, and it is for sure one of the very well studied model, and it is within its limits it completely captures the associative learning paradigm. Okay. The key is within its limits. As long as we know what its limits are, it is very useful and very accurate in predicting the observations. Good. Then what the limitations are? Let me list out the limitations here. However, in the next class we will go in depth at what the experimental evidence Rescorla had for this negative learning, and even to some extent the detailed description of the limitations by themselves. Limitation number 1, we will be talking about something called as latent inhibition. Right. And second, we will be talking about something called as an occasion setting experiments. These are two instances where we can there is also third, which is inherently the model makes an assumption that the in a compound stimuli the responses are additive. So, you call that such kind of an assumption, you call that as this is elemental inference by the model makes an assumption of elemental inference by the animal of the various stimuli present there. This need not be the case. The animal instead can have a configural inference of the surroundings. So, we will look at these three aspects and how this model fails, or how these things sets a limit on the Rescorla Wagner's model. From there on we will ask an important question of what exactly is happening when an animal forms an association. See you in the next lecture. Thank you.